of a line, and there's a couple of different ways that we can do that. First of all, if we are given the gradient, which is m, and the y-intercept, which is b, we can find the equation of a line by just subbing those values into y equals mx plus b, and we will have the equation of the line. Another option is if we want to find the equation of a line and we know the gradient and one other point, then we can use the formula y take away y1 equals m bracket x minus x1. This is known as the point gradient formula because I know a point and I know a gradient. Sometimes you want to find the equation of a line and you're given 2 points. Now you want to use the 2 points that you're given to find the gradient first, which you will need to use this formula here, or you could also use m equals rise over run if you have the graph there. Once you have found the gradient using either one of those options, then you use the point gradient formula to find the equation of the line. If you have 3 points that are all on the same line, we call that collinear. So collinear points are points all on the same line. If A, B, and C are collinear, then the gradient of A and B will be the same as the gradient of B and C. So you might have a line like this, and you might find the gradient between A and B, maybe that's equal to 2, and then you find the gradient between B and C. If that's equal to 2 as well, then those points are all forming a straight line. So example number 1, find the gradient of the line joining the point A, which is -1, 6, and B, which is 3, -2. Now, to find the gradient, I'm given 2 points. I want to use the formula y2 take away y1 over x2 take away x1. Now, we need to label our points to sub into that. Now, every point has an x value and a y value. So the first point, I'm going to call that x1 and y1. So x1 is going to be -6 and x1 is -1 and y1 is 6. The second point, x2 is 3 and y2 is -2. And we're going to sub that into our formula. So y2 is -2. Take away from the formula y1, which is 6, over x2, which is 3, take away x1, which is -1. Now, I had a negative from the formula and my number was a -1. When you have two negatives next to each other, that becomes a plus. So -2 minus 6 is -8, and 3 plus 1 is 4. And when I divide that, -8 divided by 4, I get a gradient of -2. So there it is, m equals -2. And that's finished. In question 2, it says to find the equation of the following straight line. Now, to find the equation, I'm going to need to know a gradient and a y-intercept. Now, I could find the gradient using the same method as I did in question 1, because I do have the 2 points here written on the graph. But remember that I said you can also use the rise over run method. So since I've already showed you this formula in question 1, I'm going to use the rise over run method for question 2. So gradient equals rise over run. Now, looking at the triangle that is formed by those dots, the rise, the y value was a 1 and it goes up to 16. So 16 take away 1 is a rise of 15. The run, the x values start at 0 and goes to 3. So that's a run of 3. Always check to make sure if it's a positive gradient or a negative gradient. That's sloping uphill, so that's a positive gradient. So I don't need to have any negative signs in there. 15 divided by 3 is 5. Okay, so I know the gradient. If I can find the y-intercept, then I can use the y equals mx plus b form, and I can get the y-intercept. It's right here. The y-intercept is wherever your line goes through the y-axis. So in this case, mine's going through at 1. So b is equal to 1. So then finally, using y equals mx plus b, I just sub in that m is equal to 5, so 5x, and the b is equal to 1, and that's the equation of my line, which is the final answer that we were trying to get. Question 3. Find the equation of a line that passes through the points 2, -3, and 6, 9. So we want to find the equation. So we have two options. We have the y equals mx plus b, if I know the gradient and the y-intercept. Now, I don't know the y-intercept, so that's not going to be the best option for this one. So I will need to use instead the point gradient formula. However, I don't actually know the gradient yet, so I'm going to have to find that first using this formula, m equals y2 take away y1 over x2 take away x1. So this is what we did in question 1. So again, I label these points x1, y1, x2, y2, and I sub them in. y2 is 9, take away y1, which is a -3, so 2 minuses will make a +3. On the bottom, x2 is 6, take away x1, which is 2. 9 plus 3 is 12, and 6 minus 2 is 4, and 12 divided by 4 is 3. Okay, so there's my gradient. Now that I have the gradient, I'm actually trying to find the equation, remember, and I need to use my point gradient formula, which is y take away y1 equals m x take away x1. Now the gradient is the m equals 3. The point is either one of these 2 points up here. Because I've already labeled this one x1, y1, I'm going to use that point again. So subbing that in, the y at the front will stay there, but the y1 I sub in the -3. So the minus from the formula and the minus from the 3 becomes a +3. M equals 3. The first x stays in there, but x1 is a 2, so -2. So there should always be an x and a y because we're trying to find the equation of a line here. Next, we want to expand the brackets. Y plus 3 equals 3x, and 3 times -2 is -6. And lastly, we want to get the y by itself, so I'm going to subtract this little 3. Excuse me. Subtract the 3 and I get y equals 3x minus 6 minus 3 more is -9. And there it is, the equation of the line that passes through those 2 points. Question 4, find the equation of a line that has a gradient of -4. So that's telling me that m equals -4. And the y-intercept is at 0, 2. Now the y-intercept is known as the letter b, and that is 0.02, means that the y-intercept is at the 2. So if I already have the m and the b, I can sub those into y equals mx plus b, which means y equals -4x plus 2. And that's it.